A quick explanation between the two problems that you see here and how to solve them. So, what is being divided matters greatly. In this first problem, problem 7, we see that all of 9 and k is being divided by 2. Where in the second problem, problem 8, we see only the n is being divided by 7. You can take a problem like number 7 and rewrite it to show that each term is being divided by 2. The 9 is being divided by 2 and the k is being divided by 2. But that's not the way I would solve it. When I read 9 plus k divide by 2, the first thing I would cancel is the divide by 2 because the inverse of division is to multiply by 2. And what I do to one side, I have to do to the other. So multiplying this whole side by 2 cancels the 2 on the bottom because divide by 2 and multiply by 2 are inverse operations, leaving me with just 2 times 5 is 10. 10 equals 9 plus k. Now I can solve for k by subtracting 9 from both sides. 9 minus 9 is 0, leaving me with k equals 1. So my solution is k equals 1. If I were to go back up here and substitute that, 9 plus 1 is 10, and 10 divided by 2 is 5. Or even if I took this part right here where I separated it, 9 divided by 2 is 4.5. 1 divided by 2, because we said k equals 1. 1 divided by 2 is equal to 0.5. And 4.5 plus 0.5 is still equal to 5. That's different than problem 8 because when you read problem 8, you have n divided by 7 minus 6. So the minus 6 is all by itself. The minus 6 is the last thing I said. So the minus 6 will be the first thing that I cancel. I cancel minus 6 by adding 6 to both sides. Negative 4 plus 6, different signs. So I subtract 6 and 4 and I get 2. And since the positive is bigger, the 2 is positive. So I'm left with 2 is equal to n divided by 7. And again, the inverse of this fraction line, which means divide by 7, is to multiply by 7. Divide by 7 and multiply by 7 cancel, because if I were to multiply this, I would get 7n over 7, and 7 divided by 7 cancels. So I'm left with just n equals 14.